Let's start this problem with a quarter circle, and then on the right side of the quarter circle we will inscribe a half circle as you can see on the sketch. Then from the point on the arc of this inscribed half circle we will construct a triangle whose right side is equal to 2. The question is, can we somehow calculate the area of this red triangle? So first of all, I would like to thank Jerry for suggesting me this wonderful problem. And he said that this problem was given to him as a homework in his high school. And this is going to be so much fun because I'm going to show you a 5-second method to solve this problem. But before we get to that, first I'm going to show you how to do this a regular geometric way. Because, you know, Jerry could not wrote a 5-second method. So first I'm going to label all the vertices of our triangle as A, B, and C. Then I'm going to label the top right corner of our quarter circle as D, and I will label the center of the inscribed half circle as O. Now, let's pull the line from point C to point D. And let's use the inscribed angle theorem. This theorem states that the angle, which we can label as theta, inscribed inside the circle, is half of the central angle, which is 2 theta in this case, that intercepts the same arc on the circle. Now, we're going to use this theorem on our sketch on the left. But first I'm going to label all the vertices the same as the sketch on the left, so that you can see this more clearly. Now, if we extend our half circle to a full circle, you can notice that the angle at the point O represents the central angle, which equals to 180 degrees. This means that the angle at the point C is the inscribed angle, which equals to the half of 180, which is 90-degree angle. Now, from this, we can conclude that the triangle BCD is actually right-angled triangle. Now let's have a look at this triangle. Let's say that the acute angle at the point D of this triangle is alpha, and the acute angle at the point B is beta. So now, since we know that the sum of all interior angles inside the triangle must be 180 degrees, this means that alpha plus beta must be 90 degrees. Now we can use this in our favor, because if you take a look at the overall angle at the point B, we know that this is 90-degree angle, because ABD is a quarter circle. Now, from this, we can conclude that the remaining acute angle at the point B must be alpha. Now, let's notice one more fact. Let's notice the radius AB of our quarter circle. Since this red line represents the radius, this means that BD is also the radius of the same circle. And furthermore, BD will represent the hypotenuse of our blue triangle BCD. Now, since the acute angle of this triangle is alpha, the same as the acute angle at the point B, we can take the whole triangle, rotate it, and place it on the line AB. Now the line AB will be hypotenuse of our newly formed right-angle triangle, and let's label its apex as E. Now we know that the triangles AEB and BCD are congruent, so this means that the line AE will also have the length of 2. Alright, so let's go back to our sketch. And remember, we're looking for the area of the red triangle ABC. Now you can probably notice that this triangle has the base of 2 and the height of 2 as well. And you can see this even more clearly if we take this triangle and rotate it. You can now easily see that the base BC equals to 2 and the height of this triangle EA equals to 2 as well. So it's pretty easy to find the area of this red triangle as base times height over 2. We will just substitute our values and get that the area of the red triangle is equal to 2 squared units, and this is our solution. Alright, now let me show you how to solve this problem in no more than 5 seconds by using a little bit of geometric cheating. So, in order to do this, you just have to notice one thing, that the apex of our red triangle is actually an arbitrary point on the arc of the half circle. This means that this point can be anywhere on our half circle. So we can just take this point and put it, let's say, on the top right corner. If we do this, you can notice that now our red triangle will look something like this. Now this red triangle will be isosceles triangle, but furthermore, we know that the angle at the bottom right of this triangle is 90-degree angle since it is inside the quartercircle, which means that the red triangle is actually an isosceles right triangle. And since we know that the area of right angle triangle is half of the product of its legs, you do not need more than 5 seconds to find its area. Alright, so let's try to do it in 5 seconds. So, the area is equal to 2 times 2 over 2, which means that the area equals to 2, and this is our solution. So there you go, we have the area in no more than 5 seconds. Only thing that you need to know is arbitrary point, and from there everything is quite easy, as you can see. So I hope you guys really enjoyed this video. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this. Of course, if you found a third way to solve this problem, please write it down in the comment section as you always do. And until next time, see you all and take care.